Climate change is a global problem, and while it's already affecting life on Earth thanks to things like sea level rise and more intense storms, the problems aren't just happening near the ground. Climate change also affects objects in space because, well, it's making the upper atmosphere shrink. In the lower atmosphere, where we are, carbon dioxide acts as a greenhouse gas. It both absorbs and radiates infrared light, also known as heat. So when waves of heat come off the ground and try to escape into space, they can be absorbed by the CO2 in the atmosphere. Then the carbon dioxide will release that energy, and while some of it is released towards space, some of it will be sent back to Earth to warm things up. This is what is meant by the greenhouse effect, and as the amount of CO2 increases in the atmosphere, the amount of infrared light getting absorbed and sent back to Earth increases. That leads to warmer average temperatures and the climate change we are experiencing. In the upper atmosphere, though, the story is different. As you travel higher above the Earth, the atmosphere gets more and more thin, and carbon dioxide's role changes. Since there isn't much air up there, the greenhouse effect isn't as much of a thing, but there are a lot of free-floating oxygen atoms. You don't find many of those near the ground. You usually see oxygen molecules, but reactions in the upper atmosphere produce a lot of single-atom oxygen, and occasionally those atoms collide with molecules of carbon dioxide. When that happens, the atomic oxygen gives the CO2 a bit of energy and causes it to vibrate. Then the CO2 can get rid of that energy by emitting infrared light, most of which escapes into space. Ultimately, as that heat dissipates away, the upper atmosphere cools down. So as the amount of carbon dioxide increases, these collisions happen more and more often, and the upper atmosphere gets colder and colder, and in the process, it shrinks. It's just like how a balloon shrinks in cold weather. As gas cools down, its particles have less energy and can move closer to each other. We've seen evidence of this happening in the upper atmosphere over the last 2 decades. And for spacecraft, this is important because many satellites that are orbiting Earth, including the International Space Station, are technically still in the atmosphere. I mean, it's extremely thin up there, which is why it isn't called the International Upper Atmosphere Station, but it is still the atmosphere. Normally, this means the satellites experience drag, where they're constantly running into particles in the atmosphere, losing energy, and dropping a little closer to the Earth. In fact, for satellites that orbit less than about 600 kilometers above the surface, drag is one of the main forces that they feel besides gravity, and eventually, it's what causes them to re-enter the lower atmosphere, where they burn up or crash. But as the upper atmosphere gets thinner, thanks to climate change, the amount of drag goes down, and that means satellites stay in orbit longer. Like, it could be years longer for those that are near that 600-kilometer altitude. In some ways, that's good news for companies that build and launch satellites, since their spacecraft will last longer. But it also means everything up there will stick around longer, like the used upper sections of rockets, which sometimes stay in orbit, or any debris from the occasional satellite collision. As more objects stick around, there is a higher and higher chance that they will collide, putting even more junk in orbit. This is something people think about so much that there's even a name for it, the Kessler syndrome, where space junk collides with other space junk, creating an ever-increasing amount of space junk. Also, to make the situation more complicated, the number of satellites in low Earth orbit is going to increase over the coming years as companies launch hundreds of them to provide global internet services. So we're putting more satellites into orbit, while the atmosphere is becoming less capable of getting rid of them. The good news is, we're seeing this ahead of time and people are working to deal with it, and are exploring options like a satellite traffic management system similar to the ones that exist for airplanes. They're also looking into some kind of specialized satellite that could capture pieces of debris and bring them to the lower atmosphere to burn up. There are even conferences where scientists and engineers around the world get together to talk about ways of reducing the amount of junk in space. That collaboration and problem solving is very cool, but it does also make you realize just how wide-reaching a problem climate change is. Because at the end of the day, fancy garbage truck satellites could help in space, but we will have other problems to deal with on the ground. Thanks for watching this episode of SciShow Space. If any kids in your life are space fans, they might enjoy some of the episodes we have over on SciShow Kids, like our episode about where the moon came from. So if you want to check that out, along with the rest of our kids' content, you can head on over to youtube.com/SciShowKids.